Now in this video, we're going to answer the second part of a two-part question. The question tells us to show that the sum of the series defined by R is equal to n divided by 2 multiplied by n plus 1, when the variable R has a lower limit of 1 and an upper limit of n, using the method of differences. If you find this video helpful, please consider leaving a like, a comment, sharing this video, and subscribing to our channel for more content like this. Sigma notation, also called summation notation, is a mathematical shorthand used to write out a long sum of numbers in a compact way. The bottom of the sigma tells us two things: the variable, or index, and the lower limit, or where to start. The top of the sigma is the upper limit, or where to finish. The method of differences, or the method of telescoping sums, as it's sometimes called, is an algebraic technique used to find the exact sum of a long or infinite series. By applying this strategy, we can rewrite the series as the difference between consecutive terms, creating a chain of values that cancel each other out, leaving just the first and last components. In the previous question, we found that R is equal to 1/2 of R multiplied by R plus 1 minus R multiplied by R minus 1, which means we can replace R with that expression here, whose sum we need to show is equal to the right side of the equation, 1/2 of n multiplied by n plus 1. Answering this question is a 4-step process. First, we need to set up the identity using the previous result and sum both sides from 1 to n, substituting values of R beginning with 1 and finishing with n, before solving to find the sum of R. To begin, our previous result showed that R is equal to 1/2 of R multiplied by R plus 1 minus R multiplied by R minus 1. By multiplying both sides by 2, we get 2R equal to R multiplied by R plus 1 minus R multiplied by R minus 1. And we do that because it's easier to deal with the fraction at the end. Taking the sum of both sides from R equal to 1 to n gives us the sum of 2R equal to the sum of R multiplied by R plus 1 minus R multiplied by R minus 1. Pulling the factor of 2 out on the left-hand side gives us 2 multiplied by the sum of R equal to the sum of R multiplied by R plus 1 minus R multiplied by r minus 1. Now we need to substitute values for r, starting with 1 and finishing with n. When r is equal to 1, 1 multiplied by 1 plus 1 minus 1 multiplied by 1 minus 1 is equal to 2 minus 0. When r is equal to 2, 2 multiplied by 2 plus 1 minus 2 multiplied by 2 minus 1 is equal to 6 minus 2. When r is equal to 3, 3 multiplied by 3 plus 1 minus 3 multiplied by 3 minus 1 is equal to 12 minus 6. And finishing, when r is equal to n, we get n multiplied by n plus 1 minus n multiplied by n minus 1. For a telescoping series like this, after cancelling the intermediate terms, the first and last terms are the only ones remaining. So twice the sum of r is equal to n multiplied by n plus 1 minus 0, which is just n multiplied by n plus 1. The final step is to divide both sides by 2, giving us the sum of r equal to 1/2 of n multiplied by n plus 1. So by applying the method of differences, we've shown that the sum of r is equal to 1/2 of n multiplied by n plus 1. Please follow us on Instagram, TikTok, and Threads for daily maths content.